Okay, so a halfling is a hobbit. Kinda. Close enough.
What?
Alright, so how many scouting parties of 2 elves and 2 humans can be made from a group of 4 elves, 3 humans, and a halfling? Okay. So, why is this problem different than the ones we've been doing? Okay, good.
Because
So,
you're getting
first things first,
You have an extra human.
we could, per usual, suppress the halfling. Right? No one ever needs the halfling for anything except to throw it in a volcano. So, we can skip the halfling. Hobbits are useless, trust me. It's like Marco from Captain Planet. All they ever do is spark up and lose the ring, and then dating myself with that.
Yeah, I was like, that's a really good reference.
I know, right?
Used to watch that at 4 a.m.
Okay, anyway. So why is this problem still different than the ones I've been doing?
because you're making groups for like 2 separate groups.
Yeah, there's kind of 2 different elements here, right? It's not like making a committee out of people, it's making like some little committees of humans and some little committees of elves, and then wondering how many different ways there are for this to go together. You guys see that? Okay, so let me concentrate on, I don't know, the like elf part of this. Right? So, how many elves do I want to pick?
2.
2. How many elves do I have to pick from? Okay, so is that 4 choose 2 or 2 choose 4?
4 choose 2.
4 choose 2. So you can clue yourself into the fact that it's going to be big number choose little number all the time.
Okay.
If you try to do it the other way, everything will break.
No, you just have to clone them.
Yeah, basically what it's saying, right, if you did 2 choose 4, is that you have 4 slots to fill with 2 people. That ain't going to happen,
Okay.
right? You guys see that? So this is 4 things filling 2 slots. How about the humans? There's 3 humans to fill 2 spots. Okay, what do these represent?
The race-specific group.
Each half of the committee.
Yeah, this thing here is the number of ways, right, to pick 2 elves out of 4 elves. So that's the number of ways to get the elf part of this committee. This thing's the number of ways to get the human part of the scouting party. You guys see that? What operation should I do between these 2 things?
Another choose.
Oh, kind of. No.
Just straight multiplication.
Why? Why would it be multiplication?
Because if you have 6 ways to arrange one thing, it's the same thing as choosing the hats and the pants and the.
Good. Yeah, this is
the coats.
pants and shirts, right? You guys see that? So if you sit down and make a tree with this thing, right? So the first thing you're going to do is you're going to start out with your little group, right? And then to make a tree, you're going to say, okay, let's pick an elf part of this committee, right? This would be like elf option 1, right? This other arrow is going to be elf option 2. And there's going to be just a ton of these arrows, right? Because there's 4 choose 2 ways to get the elves. Is that? That's not actually so many options, but there's a few.
If you were making this tree, what would you do with the 2?
So I would figure out what number this is. So let's figure out what number this is. So this is 4 factorial over
2 factorial
2 factorial
times 2 factorial.
times 2 factorial. Good? So this is 3 factorial. There's 6 ways. So if I was doing a nice job with my tree, I start out, right? And then there's elf option 1. There's elf option 2, elf option 3, elf option 4, elf option 5, and elf option 6, right?
Wait, how do you have 5 and 6? You only have 4 elves.
I only have 4 elves, but I'm picking them in pairs. You guys see that? Do you want me to write this down more precisely?
Yes.
Okay. So let's name our elves. So what are your elves' names?
Bob.
Jimbo.
These are
Jimbo.
elves, not hillbillies.
Juan
John.
and
Arnold.
Arnold. Oh, I should make them so they have different first letters. I learned to spell Consuela the other day, and I was really excited about it, so I'm going to use that one. Okay, so these are your elves, right? Now, you need to pick your scouting party of these elves, right? So I think you have Bob and Arnold as an option, right? Bob and Consuela is an option. Bob and Juan's an option, right? So that takes care of the arrangements with Bob in them. Okay, so check, I'm done with Bob's. Now, what are the other options with Consuela in them?
You compare them with either Juan or Arnold.
Okay, so Consuela and Juan or Consuela and Arnold can be.
And then Juan and Arnold.
And then the only other option I haven't covered, right, is the Juan Arnold option. Okay, so these are my 6 elf scouting parties, right? Like the elf half of my scouting parties. Okay, how about the humans? What do you want to name the humans?
Reginald,
Alice.
Reginald? No, they need to be different than those letters.
Tyler.
Eve.
So Reginald, Tyrone,
Jeff Lemon.
and
Eve.
Eve. Sure.
Pretty sure Eve is an elf now.
This is one heck of a party.
Okay,
Can we switch Eve?
so no, we're gonna do this.
Eve and Bob definitely we switch.
Okay, so what are your options for your human chunks of the scouting party?
Reginald and Tyrone. Reginald and Eve. Tyrone and Eve.
Okay, so you got Reginald and Tyrone, Reginald and Eve, and Tyrone and Eve. That's your 3 choose 2 ways. You guys see that? So what does your tree actually look like here? Your tree looks like, okay, there's 6 elf options. So there's Bob and Arnold, there's Bob and Consuela, there's Bob and Juan, there's Consuela and Juan. I know, I'm writing them down again and it's a waste of time. Anyway, so there's all these options for the elves, right? And then from each of these, there are how many options?
3 options for the human.
Yeah, good. So from this one, the Bob and Arnold elf team goes with one of Reginald and Tyler, Reginald and Eve, or what was the last one? Tyrone and Eve. And then kind of continue this, right? You guys cool with this?
Yeah.
Okay, in my head
So-
I was starting the tree with choose one elf, choose the second elf.
Yeah.
Choose, but
So
it'd
you-
be really easy to get repeats in there.
You could do that, but then you have to be very careful about counting the arrangements. It's much easier to think about, okay, let's take care of the humans first, take care of the elves first, then the humans, and then we'll just take these numbers and multiply them.
So that
So-
is what you would do though if like order did matter, like which one gets picked first does matter.
Yeah, so if we had to, right, if we were gonna send 2 elves and 2 humans on suicide missions in order or something, like how many different ways are there to kill these characters off in order in the book, then the order would matter and I'd be doing permutations instead of choosing. Right, but here this is just strictly like, I'm gonna grab some, it doesn't matter what order it happens in.
And ultimately, it is multiplied by 1 at the end by the halfling.
Yes.
Like this.
And there's only one way to pick no halfling.
I missed why you
You guys see that?
check mark Bob and Swayla. What was that?
Oh, okay, so as I was going through here, I was trying to establish what were the 6 ways that I got out of 4 choose 2. So I did this a little bit like I do distributing multiplication, right? So there's like Bob and Consuela, Bob and Juan, Bob and Arnold. So once I was sure I took care of all the options with Bob, I checked him off.
Oh, so you just hadn't finished yet.
And then I went through and did the Consuela options, right? So Consuela's options are with Juan or Arnold. And then I checked Consuela off. And then there's only one way for these 2 to go together. That's this last way. You guys see that? It's just like, when you're combining like terms, you might want to keep track of which
Yeah, I thought
ones
you were
you've
saying
already
like
used up.
they had, one of those 2 had to be in there. Okay,
Yeah, sorry, if I was doing this more appropriately, I would have finished that thought with, okay, and now we checked off Juan, because Juan can only go to, with Arnold, and then the Arnold options are already checked off. You guys see that? Okay, so ultimately here, what's my answer?
18.
18. There are 18 ways to make this work. Cool?
Where did you get your second 2 from down there?
Top. So n choose r is n factorial over n minus r factorial times r factorial. Remember the formula from last time? Okay, this is the formula.
Okay.
And the reason for it is, these are the permutations for n things permuted r ways. That's this guy. That's n things filling r slots.
Okay.
And then this guy comes from saying, and the order doesn't matter, so you want to cut out rearrangements of the slots.
Okay.
It's the formula.
Got it.
It's not magic, but yeah, it's just the formula.
Okay.
You guys cool with this?